Hey there, it's Workbench with Workbench Quagmire. We are working on our Free Code Camp Python certification in 100-ish days. We're back here on error handling. We're going to do a couple more of these theory sections today with the quizzes. And then I think tomorrow we move on to a lab or a workshop or something. So let's get started here. How does exception handling work? In Python, exception handling is a core part of writing robust, fault-tolerant programs. It allows you to anticipate, catch, and respond to errors in a structured way. Exception handling is the process of catching and managing errors that occurs during execution of a program, so your code doesn't crash unexpectedly. Python provides the try, except, else, and finally blocks to gracefully handle errors. Here's a basic example. So try x equals 10 divided by 0, except 0 division error, print you can't divide by 0. The try block of the code is where you anticipate an error might occur. This block, the except block, runs if an error of the specified type is raised inside the try. In this case, dividing by 0 raises a 0 division error, which is then caught and handled. And there is an example also showing how to use the else and finally blocks. So here's our code here. This time we're going to divide 10 by 2, 0 division. We're not going to have that error. And then else, print division successful, and prints the value of x. Finally, the block always runs. So else runs if no exception is raised in the try block. So in this case, it will run the else, and it'll also run the finally, because finally runs no matter what, whether or not there's an exception occurs. Useful for cleaning up tasks like closing files or releasing resources. So I think try and accept is frequently used when opening files. So you can say try, accept, and if there's an error, and then finally you can close the file, because that's something you have to do sometimes. You can also catch multiple exceptions with separate except blocks. So here's an example of that. Number equals int ABC and result equals 10 divided by number. Have value error for that's not a valid number for our first error there, and 0 division error. I can't divide by 0 will be triggered by the result equals 10 divided by number. By using separate except clauses, you can make your error responses more specific and useful. You can also use exception object, which is typically alias to another name with the as keyword. Here we're using E as an alias for the error object. So try, just going to 0 division as E, and then print like a formatted print statement, error occurred, and then it prints the error. So using E lets you access the actual error message or object for logging or debugging. You can also catch multiple exceptions in a single except clause by specifying the exception as a tuple. So here's an example of that. Except value error, 0 division error as E, and print an error has occurred. So in that case, it's less specific, but it's a little more efficient. Exception handling allows your program to recover from errors gracefully by using try, except, else, and finally. You can anticipate potential issues and build more resilient applications. What does the try block do in Python? It ignores errors completely. Nope. It defines a block of code to test for errors. Yep. It deletes all exceptions. No. It stops the program immediately. Now, that would be very useful. When does the finally block execute? Only when there is an error. Is no error? Nope. Only when an exception occurs? Nope. Always, no matter what? Yes. Only if the else block executes? Nope. Which statement is used to catch a specific error? So that would be except. So I don't think catch is one of our options. Yeah. Handle, catch, no, try. There we go. Now, understanding error handling. What is the raise statement and how does it work? In Python, the raise statement is a powerful tool that allows you to manually trigger exceptions in your code. It gives you control over when and how errors are generated, enabling you to create custom error conditions and enforce specific program behavior. The raise statement is used to explicitly throw an exception at any point in your program, allowing you to signal an error condition has occurred or that certain requirements haven't been met. Python raise statement can be used in several ways to trigger exceptions. At its most basic, you can raise built-in exceptions or create custom error messages. Here's an example. So we define this check function, takes age as an argument. That was the word I was looking for, I think, yesterday. If age is less than 0, we raise a value error, and we get age cannot be negative, and then return age. So try check age -5, accept value error as E. So print F error E. So here is where the raise is where we define what we want the behavior to be when there's an exception. And we mirror these value errors. And then obviously our actual output of the error is what we put here in this string. So you can see the raise keyword is the raise keyword that triggers an exception. In this example, we're raising a value error with a custom message when an invalid age is provided. The raise statement can also be used to re-raise the current exception, which is particularly useful in exception handling. So find process data, try result equals int data, return result ×2, accept value error, print logging invalid data received, and then raise. We re-raise the same value error. And then, so we try process data ABC, it's not an int, accept value error, print handled at higher level. Here the keyword raise without arguments re-raises the current exception that's being handled. This allows you to log or perform a cleanup while still propagating the error up the call stack. You can create and raise custom exceptions by defining your own exception classes. So here, this is a jump forward. We're talking about classes and we haven't really talked about classes yet. So it's kind of an interesting jump. So class, insufficient funds error. We have to give it the argument exception, and then define int init self balance amount, self.balance amount, super init insufficient funds balance. So define withdrawal balance amount is greater than balance, then raise insufficient funds error with balance and amount, return balance minus amount. So try new balance equals withdrawal 100 150, accept insufficient funds error as E, print transaction failed E. As you can see, the custom exception classes inherit from exception. It is subclasses. So exception is a class. Kind of surprised me we're getting classes this way. You'll learn more about classes and inheritance in future lesson. I hope so. For now, this is a way to create your own exceptions with custom logic. The raise statement can also be used with the from keyword to chain exceptions, showing the relationship between different errors. So in this case, we define a function parse config. We give it the argument of file name. So we have a try block with open. Here's where it said files, the file example from earlier. With open file R, that's read as file. Data equals we read the file. We return int data. So we're assuming data is something that can be turned into an int, except file not found error. So if we try to open a file and I can't find the file, A raised value error, configuration file is missing from none. And then a value error, except value error. So if we, turns out this is like the ABC example earlier, we'll raise the value error as E, raise value error invalid configuration format from E. And then config equals parse config, and then we give it a file here. As you can see here, that raise from none suppresses the original exception context. For example, here's the traceback, most recent call, line 12 and module. And really, these are much easier to read if you start at the bottom. Oh, the configuration file is missing. Value error, configuration file is missing from none. File name. So file name line 7 and parse config. So in the function, and then here's where it was called on line 12. This would have been line 12. It'd been helpful if they put line numbers there. So yeah. You can also raise exceptions conditionally using assert statements, which are essentially shorthand for raise with an assertion error. So we define this function, calculate square root. We give it a number. Assert number greater than or equal to 0. Cannot calculate square root of negative number. Yep. Return number, square root. And then try result equals calculate square root minus 4. Accept assertion error. And then print assertion failed with the error. The raise statement is essential for creating robust applications where you need to enforce business rules, validate input, and provide meaningful error messages. By strategically using raise, you can make your code more predictable and easier to debug while giving users clearer feedback about what went wrong. This is one of the things I didn't end up using in my project because we hadn't talked about it yet. But there's a lot of cases like when we're checking, so using like the is instance situation where we're like saying, well, if it isn't an instance of int, then return something or print something. This would be basically you would assume it's going to be an int, put your code inside of a try except block, and when it's not, you give the feedback that hey, this was not an int. Try again, and then have your program loop back around and ask for the input again. So what does the raise statement do in Python? It does not catch exceptions. It manually triggers an exception. Yep. It ignores errors. No, it fixes broken code. If only. What happens when you use raise without any arguments? It raises a generic exception. It does nothing. It re-raises the current exception. It raises a type error. It re-raises the current exception. Which keyword is used to chain exceptions together? With, no, from, yes, no, chain, no, link. Sorry, that's just funny. Chain link. All right. We're done with that. So, tomorrow, we're going to do the debug and ISBN validator. Probably using a lot of our error handling techniques we talked about in here. So thanks for watching this video. Don't forget to comment, like, and subscribe. And I'll see you tomorrow for this debug and ISBN validator lab.